Assalamu alaikum, welcome back to my channel. Last time we learned about this substation. I hope you remember in my previous video you can see this one, and we put 8 panels for the 8 row of villas, or you can call house, whatever. So the actual substation will be, the drawing will be look like this, and this is the concept. So if you learn this one very well, it's very easy to understand this one. So if you see, this is one kind of substation room with many things. Actually here we have 3 transformer. So this is HV room, same like HV room here, and then transformer room, same like transformer room. Then the MV room, what is here is MV room, and there is no LV room here because this one will provide the current, the power supply direct to the building. So there in individual electrical room has some SMDBs. So we have provided one LV room here because I don't want to provide anything outside. So at this side, if you see, there is the generator here. So from the generator there will be a power supply here to the certain one panel, not to the all panel. I will explain you that one. So you see this one all trench. The trench, the HV trench normally 1.2, sorry 1.5, and by 800, and then this one will be 1.2, the other trench. This one can be deeper also as per the site condition. This is not default, but some project they used to maintain this one as default, but this is the minimum. So you can go maximum as per the site condition. I make one substation is very deep, like satellite project. It's very deep, and the manhole size also look like one big big house. It's a very complicated drawing. So just keep in your mind, this is 1.5 normally and 1.2. It can be go 1.8 up to and 1.5 sometime LV room. This is depend. And you see this one all plate, so we call checkerboard plate. I hope I mentioned. No, it's called checkerboard plate, and these are entries. You see here 3 nose, 3 by 6 nose, 160 mm dia, PVC sleeve for MV cable, something like this. It depends how many cables and how many ducts. And then the main thing I didn't tell in the previous video, normally I'm working in Qatar. Normally Qatar, they are giving 3 core 240 cable. So you may have big cable from the MV room, like 4 core or 3 core 240, or 2 core 3 core or 4 core 300, and you may have 4 core 300 bunch of cable. But the HV room only get one cable because we have only one transformer, only one cable. Even you have 2-3 transformer, only one cable will come, and it will be distributed from here. The one cable will be 3 core 240. It's one cable. Why? Because here coming 11 kilowatts. When the volt increase, the ampere will be less. When the ampere less, the cable will be smaller. If you see in the road, it's a high voltage, 11 kV, 66 kV kilovolt coming through the towers. That one all you see very small cable. The reason the cable is becoming small, the volt is high. So as a thumb rule, let's say we are using 240 volts, 240 watts V, 240 volts. So let's say I have 1 kilo power. So if I have 1 kilowatts power, if I divide it by from 240, this will be 4 ampere. So I have to choose the cable for 4 ampere. So let's say it will be maybe normal size, any 4 ampere which can handle cable size, normal size. So if I have volt, let's say imaginary volt 500 volt, the ampere will be 2, then cable will be smaller because the cable has to handle only 2 ampere issues. So let's say I have 1000 volt, then ampere will be 1. So increase of volt, the ampere will be reduced, and the ampere reduced, the cable will be smaller. So here I have 11 kVA volt. So let's say I am using 5000 or 10,000 or 1600 watts, kilowatts, let's say 1600 kilowatts. So I have 11 kilovolt. So how many ampere will come? Very less. You have to make this formula which I told you before, but it will be smaller ampere. So that's why the cable smaller. But from here also same will come to the transformer. I will explain you in the single line diagram. But from here the out will be big. Normally in Qatar we use sometimes 7 cable. If it is single core, 800 cable. Why 7? 2 red, 2 yellow, 2 blue, and 1 neutral. So remember, when we are getting here, there will be no neutral. When going out from the transformer, there will be neutral. So if you are electrical engineer, you will know why, the reason. If you are not electrical engineer, just Google it. It's you can learn it. There is nothing you cannot learn. If anyone says you cannot learn, your mind is small, you cannot understand, kick that people and learn yourself. It is possible. So don't let other people let you down. Everything is possible. If you try hard, you can learn it. Because some people told me when I am learning time, oh, you will not understand. And what is your qualification to understand? Something like that. Forget about them. Anyhow, the paste-based thing, whoever invented, he don't know anything about this, just he invented. After that we are learning from him. So the person who are talking about the current, he don't know before what is current. He learn everything the possible, and then he understand the current and he made the theory. Now we are learning the theory. Something like that. So don't worry about the people who ever tell you cannot learn, you will not understand. Kick that people. You search yourself. There's a multiple source in internet. You can learn. Because I face same problem. So you can learn it. So here will be 7 cable out. Will be single core. So 2 red, 2 yellow, 2 blue, 1 neutral. And if it is 630 cable, normally it will be 10. 3 red, 3 yellow, 3 blue. So it will connect to here. So from here, the cable out, whatever required size as per the load, as per the ampere. So this one is general. So if you have very small transformer, normally you will not get this HV panel. If you have very small transformer, or maybe some project you will not have transformer. So normally the transformer, in my experience I have faced in this Qatar project, 1600 kVA, kilovolt ampere, and I have faced some 2800, I think 2800. Let's see this transformer. It's not mentioned here. So there is 2800 also I face, and 1600 as I remember. So now if you don't it's not actually necessary, it depends on the project, can be changed. So I hope you understand. Now we made a single line diagram as we see before, this one. Now this one is related to each panel of this. Now we are going for this one. So it's a MDB, or you can call MB panel or MSB, whatever you name, even you can call on your name and put it there and you can do it, but it is not acceptable in the project, but it's just a name, that's all. This is what I want to tell you. And this also, it can be SMDB, SMSB, or any other names. So don't worry about the names, just understand the concept. So let's go for here. So we have total connected load each panel. This is typical. So we have each panel 257.6 kilowatts, 152.64 kilowatts. So we provided the ampere rate. This is 630, so it cannot be 630. Why? So total connected load is 2576. So if you go to the calculator, so we will go with the connected load. Two five seven into 6. So if I multiply by 1.54, I hope 1.54 it came when we make the formula. You can go for the reverse. So how many ampere? It's 3960. So we can go for 3950, meaning almost 400 ampere. So let's see some here. Yeah, we can go 400, or I don't know, I don't remember what's market available, but we have to go more than 400. So 630, I think let's keep 630. Okay, so the formula 1.54, I hope you remember we made before. This one. I hope you still remember if you are following my video. Okay, and let's start sell the SM meaning MDB. So I copy this one, copy. I will just keep beside here. So let's start from here. So let me delete this one. Is no need. This is just lug, sorry, gland. So just indicating there will be a gland here. Check the what is the gland in the Google if you are not remember. So I will copy one of this one, SMDB, Control Shift C, click, and come here, Control V. So let's rotate. Let's make smaller. So I will copy this one, this text. This is total connected load, total demand. Let's copy it with the name. So I will put it here. Let's make little smaller. Okay, before going that one, let me finish this one first, then I will go one by one. So here, what name I put? SMDB compound. So I don't want to go all the names, just we will go shorter name, and I will copy this one. Okay, let's put it here. So this is one. So it will be continue 1 2 3 4 5 6 7 8. Okay, so let's delete this all. I don't want it now. Also I will delete this. I don't want this also this. So I use 630 here, also I can use 630 ampere MCCB, and let's keep this, let's delete this guy. So 630 ampere, what will be the cable? So I don't want to go to the Kaharama books again, but you know how to go Kaharama books. This were here they use 16. So there's one table here, cable table. So here they use 4 core 150. And what cable we use here? 2 run 4 core 240. That means there's more load. So I will copy this one. I will not copy that one, I will copy this, because we have more dot CO, enter. Maybe they use that one because they have very lower load. So let's rotate this. I will go to the load and check for this one. I copy from here. The load is 118.75. How much load we was having? 257. Yes, their load is very low. So let's make smaller. Yeah, I will remove this. I will go with the enter. I will go with the text. So let's make little up. Let's match this one. So I will make this one little down. Making is taking too much time instead of explaining the things. But what to do? We have to make. Let's make down. We need to make only one. The same concept, you have to put the voltage drop here. First you have to put the length. We cannot put the length now, so I will put 0 0 and VD. Let's make slash. And we cannot put the video also because we are not doing the accurate work. So you know how to calculate. If you don't know, please follow my other video. Okay. So I need like this 8 numbers. So let's copy this one. Okay, something selected. Block. Let's make SMDB1. Pick point. Yes, here. Okay. So let's copy this one. 2, 3, 4. Let's select something here. Or let's make extend this one. Yeah. Let's delete this one. So I can go reverse like this. 6. then copy another one. Okay, let's put it here, 8. So name it 1 2 3 4 5 6 7 8. So we have to put some spare. This one already you know. So let's come from the beginning. So let's start. So this is transformer, which is here. This one we will not mention here HV panel here. That will be a separate drawing. And this total is MDB. And this is the capacitor bank. Actually this is power factor PFC mentioned, but actually this is a capacitor bank. So let's type this one, capacitor bank, and this one 250 kVAr. What's used here, we will use same. So this all 630 ampere as I told you before, and this all SMDB 1 to 8 we know spare. So it's not different between SMDB. SMDB, if you see here SMDB, it's look like similar. It's not big different, but there's a little different only. So here transformer connecting and to the breaker. So this is 2500 ampere 4 pole breaker. So you see here 0.29, and they have provided in the cable list 29 meaning. So this one 6 by 1 core 800. So I told you before, actually it's a 7 run, 6 core 108, 1 core by 800 mm. This is a different kind of cable. So we can consider XLP this one. So the CPC, it's like a neutral cable. So if you see here, as I told you before, if 630 will be 10 cable, it's 800, so only 7 cable here. And these are the default setting in the, if you see in the panel, these are the default settings. It's RYB, the color rating, and this one, all you will see. So you see here 2 BMS. So this meaning this point can be controlled by BMS system. So they have connection. It can be modified as per your requirement. Like if you want to operate this panel through internet, also it's possible. It depends on the manufacturer. But the main thing here, the transformer and the breaker, and these are default. You don't have to by heart this one, no need. Just if you found one, if you have one of this template, just you can continue. And if there is additional, you can edit. So there is nothing big different. It's a simple thing. Either you make one transformer like this. Actually, this one you can copy this one and put one line and connect this everything. Even you didn't mention these things, it's not an issue. Just you need to put the breaker, how much breaker you want. So as I told you before, this one is 1600 kVA. So this one 11/0.400. It's a dry type. So this is transformer, this is building number, but we will keep just transformer 1. No need extra details. Location, not a same transformer room. So what else? That's all we need to know. Same like SMDB. and this is capacitor bank. I already told you where it will be connected, so you can check in the Google as I told you in my previous video how it is connected. You see something here, say this one, this is earth pit, we are earth bar, so this two will go for the earth pit. Then from the earth pit there will be go to the earth bar, then from earth bar it will connect it to the panel. So whenever you see cable, I told you this one, see here to run 4 core 240 mm to XLPE cable. So this is one run 1 core 120 mm to PVC ECC. This earth cable came from where? It can come from here. I hope you understood. So what is earth bar? Let's check. Earth bar, or 6-way or some any way you want. This is called earth bar. So this is disconnecting link and this is disconnecting link. So what is earth pit? This is earth pit. Something like this. The actual is look like this. I will teach you this everything in another video, but you just know what is this. So we will check something. Earth bar in substation room. Earth bar in substation. Yeah, let's put substation. So this is what I told you. So this is how it will be connected, and say this is also this in the electrical room or MV room, anywhere. This is the way the earth cable will connect. So let's go for the drawing again. So I need to tell you some interesting thing here. So you see here this is ATS. So let's put ATS 00. Let's keep ATS 1. So what is ATS panel? This panel will have incomer two type of power. One power will come from transformer MDB, then it goes to the ATS panel. Another power, you see another diagram I have keep here, but this one feeding power from generator. So what I told you before here, so this is the generator feeding here. So how this one will come? Generator, it will go to the panel. So which panel? This is MDB, let's say 1E, let's consider 1E. So this is a ground floor generator room, MDB 1E. So this generator, you will have 630 ampere breaker from generator to the MDB. So this generator, how much power provide? Meaning generate power 300 kVA. So if you have 300 kVA, if you multiply with the power factor, you will get the watts. How much watts you can get from this generator? Like if you have 300 kVA into what power factor, maybe 0.9 or 0.8, you will get kW. This one also have same earth bar everything, and the from MDB same as this one, same as this, not a big different. We have 630 ampere for pole MCCB, and it will be another bar, then it is connected multiple breaker with the breaker. So one of breaker giving power supply to this ATS. So this ATS will power give the supplies for SMDB-1A. Let's put one. This is what I didn't mention here. You will not find here because I didn't mention it. So in case of power failure, from the government power failure, this switch you see here, it will turn to here. So this ATS meaning automated transfer switch. So this is 160 ampere because here we have 160 ampere. So if it is 630, it will be 630. The cable you can calculate as I told you in my previous video. So generator, in case of power failure, generator will start and this will be changed to here and the power will be given to this SMDB 1E. I hope you understand. Then when power come, it will turn to here. So there is some settings in this panel. So like relay, I hope you understand relay, conductor relay. Some kind of this kind of panels it's available, like relay available inside. So this relay you can learn from the Google, but I will tell. Let's go to the CAD. Okay, so let's say this is a power connection and I have another connection something like this and another connection like this. So this is NO, we call normally open, Let's copy this one. Normally open. So there's another one, but same, it will be close. NC. Normally close. So when they are given power here, there will be some coil something. There is a common power. If you see in the relay, you will know. Let's go to the image. Okay, let's see here. I need a good visible one. You see here this one, NONC, this one, and this is relay coil. Okay, just check in the Google, you can learn very fast. So I will tell you just general understanding. So when the power is on, this will be closed and this will be open. When the power off, this closed will be go to the normally open, normal level, and this one will return to closed level. So let's say we have power from government, this one from government. Okay, so this is connection, let's say, okay, something like this, and let's connect this one also here. So this is government power supply, so this one normally close. Let's go for this one, government supply here. So this is normally open. So when there is a power, the coil will be run. So this will be what? It will be closed. When there is a power, this will be closed. When the power cut, when it is closed, and this is normally closed, and this will be open when the power comes. Then there is a power exit. This will be open to the coil. So when the power come, when the power is active, government power, and this one will be in the closed position. So this will be in the open position. So the power will come like this and it will supply. When the government power off, this will be normally open, meaning it will be go to the normally open position, same what I draw here, and this will be closed position. So this one will give the generator power. Jenny. So I will draw another one. So this one will be down. For the understanding, I don't want to draw again. This will be down. Let's put this one. Okay. So this one, when government power available, I believe you understand. When the government power available, I think spelling mistake, but we will focus on the technical detail. Government power available. This one it will be closed position and this one will be open position, same like this. Okay. Yes, this is should be here. Then the when government supply not available, it will retain to this position. So normally open will go to the same and this one will be closed, the generated power will be go. When the government's power available, the normally close this government will be the go to the normally open into the closed position and the gen normally close will be in the open position when power available. I hope you understand that is happening inside this ATS. So I will explain again. When the government power available, the coil will be run normally closed will be in the open position, normally open will be in the closed position. When the government power not available, the normally open will be go to its current position and normally closed will be go to that current position. So here we will connect generator, we will connect with government. I hope you understand. If you don't understand, repeat it 2-3 times, you will understand. Still you don't understand, go to the Google, it will explain you more clear. So this is what is happening here. So what kind of machines, what kind of item we can, this DSMD we can give powers. So normally, let's say, let's go to there. Before going there, I will put something here. So here, so let's put another one. It can be feed many, but I will put only one. Let's put feeder pillar. What is feeder pillar? It is same like a DB or SMDB. You can consider whatever you want. If SMDB, if it is SMDB, the panel will be look like different, but it can be feed also. Just like I am telling, this is let's consider as a DB. So this one, we will put one panel here. Let's copy one of this. You can draw the cable tray for that one also. So let's say this is feeder pillar and let's say we have straight light like this. Let's make one hatch. So let's consider this one as a straight light pole. Let's copy. enter, click array, let's put 30, right, fit. So this light we can connect to this. We will put another DB here. Let's copy from here. Let's put it here. It's big. Let's make small. This one is feeder pillar and connecting to this light. So what happened in the night time? So in night time, in case of power failure, this feeder pillar will feed the power here. So this is what happened when we put something like this. So next thing we will continue in the other video. So inshallah we will meet in next video with the rest of the things, and check this video 2 times and understand what I try to say, and we will meet in next video. Take care, bye.